Okay, this is video PS26BBlake, and we are in week 26. And we just finished naming and writing chemical formulas for ionic compounds, a give and take, positive and a negative from either end perhaps. But these have polyatomic ions in them from table 4. And yes, you'll have that table. No, you won't have to memorize these. Now, let's go to page 571, number 20 through 24. Now, ideally, you would have turned in the assignment that had a number of things on Friday. It would have had the binary ionics from this worksheet. It would have had 17, 18, 19, 14, 15, 16, and then 20 through 24. But on and then I would have hopefully graded that, or you've got it to turn in Monday, today. Gave it back to you when you continue here. If you don't have that paper, go ahead and continue on another paper. You can take a picture of that and send it to me or something. On number 20, though, we only did potassium iodide, and there is at least one, I think there are 2 binary molecular compounds in here. We're going to save those for after the test. The 2 that were left that are binary, or that are ionic compounds that have polyatomic ions in them, are magnesium hydroxide and aluminum sulfate. Now, I'm not going to give you hydroxide on a quiz or test because I want you doing, if it's ide, it's binary. But you can do it here in the homework. And on number 21, we already did Al2O3 because it's binary. It's only got 2 things in it, aluminum and oxygen. There are a couple of binary molecular things in there that we will save later for after the test, because that naming system is too different from this. Okay, so you had to write chemical formulas for magnesium hydroxide and aluminum sulfate, and name BaClO3 NH4Cl, and Mg3PO4 Now the naming is a little easier. All of you've got to do is use this table to find these guys, and that's the second name. Second name, 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 all those are negative. The only one that's positive that's going to be a first name is ammonium. So you're going to have, if you look from that list, barium, always 2 names, no matter what, for the next, this year. Barium chlorate, ammonium chloride, magnesium phosphate. The naming is a little bit easier. I'm doing 21 first here. Barium chlorate, ammonium chloride, magnesium phosphate. There is a hydrate in there. That .4H2O just means that you've got this. Apparently it was given as MgPO4 or magnesium phosphate .4H2O. I didn't look at it. Let me check here real quick. Yes. So you can name that part. Maybe I'll put it on there as a bonus question or something. But if I have a .4H2O, it just means that there's water stuck in there with it. And this would be magnesium phosphate tetrahydrate. So later, the 2 examples that are in here are SO2 and PCl3. Those are binary molecular, so we're not going to worry about those right now. We'll do that after the test. Now I do want you to notice with those, it's S and O, those are both nonmetals. It's P and Cl3, those are both nonmetals. That naming system for covalent compounds where they're both nonmetals is different. So going back to 20, you're going to have to look up hydroxide and sulfate in the table to name them, which is OH minus and SO4 2 minus. Again, I won't give you hydroxide on the test. So it should be magnesium gives 2 from back here. Oxidation number 2 positive. Hydroxide took 1 because it's OH minus. They don't match. I need 2 hydroxides. And the way you do that is you put a parentheses around and I get 2 of that whole hydroxide. The other one, aluminum sulfate, alum. Aluminum gives 3. It's right here, oxidation number 3 positive, it's under boron. Sulfate took 2. So aluminum gave 3 valence electrons, sulfate took 2 valence electrons. This doesn't match. We'll have to move 6. So we'll have to have 2 aluminums. These count electrons. These count atoms or polyatomics. I'll have to have 2 aluminums, 3 sulfates. Oh, I have a mistake there. That should be a 3. Should be a 3. Okay. Aluminum sulfate, Al2SO4 alum. You can buy that and go to do pickling at the grocery store. Okay, let's go on. Let's practice. Sodium carbonate, potassium nitrate, calcium sulfate, sodium bicarbonate. How do you rate those? Well, let's write them over here. First of all, I know these ions because I've been doing them for 40 years. Carbonate is CO3 2 minus, nitrate is NO3 minus, sulfate is SO4 2 minus, and bicarbonate is HCO3 minus. Those are all in that table 4. Sodium and potassium are in the first column on the left. They're alkali metals. So it's Na positive and K positive. In the next one, you have so sodium's Na positive down here. Calcium's an alkaline earth metal at Ca2 positive. So let's put these together. You can't leave the charges in there, so I'm going to write the answers over here. So sodium carbonate is Na, and carbonate is CO3, but how many of each? Sodium gives 1 valence electron, carbonate takes 2, not a match, I have to have 2 sodiums. There they are. Potassium gives 1 valence electron, nitrate took 1, that is a match, 1 of each. Calcium gives 2 valence electrons, sulfate takes 2, that's a match, 1 of each. CaSO4. Down here, sodium gives 1 valence electron, the bicarbonate ion took 1, that's a match. So just should be NaHCO3, 1 of each. Okay, and as I turn the page, that's what I'm going to have. So let's go. On ammonium chloride. Ammonium from table 4 is NH4 positive. It's the only polyatomic ion you have that's positive. Chlorine is over there on the right, next to last column. Takes 1 Cl minus. Potassium phosphate. Potassium is all the way to the left, K positive. Phosphate is from the table, PO4 3 minus. And here I have ammonium phosphate, which is NH4 positive, and phosphate's PO4 3 minus. So it would look like this. 3 ammoniums, and a phosphate. Now let's get to that. So we have an ammonium that gives 1 electron, chlorine that took 1 electron, they're a match. So it should be NH4Cl. Don't leave positives and negatives in your answer. If you do, it's wrong. Potassium phosphate. Potassium's giving 1, phosphate takes 3, not a match. How do you make it match? You need more potassiums. As a matter of fact, you need 3 potassium. K3PO4. Get rid of those. And ammonium phosphate. Ammonium gives 1 valence electron, phosphate took 3. These don't match. How do you do that? You get 3 ammoniums. Well, how do you get 3 of those? NH4, 1, 2, 3 of them, and a PO4. That's ammonium phosphate. Good fertilizer there. If you need phosphorus on your crop, and ammonia, and nitrogen, you'd use that guy. Okay, so that's what we have here. So we're going to have a quiz over this. Some for credit and some for bonus. If you're marginally decent at this, if you try some, you'll do okay. So it's nothing to panic about. So there's some bonus in there if you're good at it. So let's try some mixed practice. Calcium sulfide ends in "ide", so it's binary, which means it has calcium and sulfur. Calcium, if you look here, I'll tell you how many of these give, but if you look this up, calcium's given 2, sulfur's taking 2, that's a match, so it's just CAS. Sodium nitride. Sodium is Na, it ends in "ide", so the only other thing in it is nitrogen. How many of each? Sodium's here, gives 1. Nitrogen's here, takes 3 valence electrons. That's not a match. How do you make it a match? Have a total of 3 nitrogen sodiums. You need 3 in. Magnesium acetate. Okay, this doesn't end in "ide", which means, except for this one, it's a polyatomic ion. And that polyatomic ion, if you look it up on the table, is acetate, which is C2H3O2, -1. And the magnesium is Mg. You have to put the positive one first. Here, 2 positive. Gives 2. Takes 1. Not a match. I need another acetate. So I need another one of the whole thing, so I have 2 of the whole thing. That's magnesium acetate. Aluminum chlorate. Not an "ide". It's polyatomic. It's a polyatomic ion. And the chlorate ion is ClO3 -1. And the aluminum is Al. And if you look here, right there, gives 3. Al3 positive. So aluminum gives 3, chlorate takes 1, not a match. Aluminum gives 3 valence electrons. Chlorate took 1 valence electron. Not a match. How do you get them to match? Have 3 chlorates. And you show that, I put in parentheses, and there's 3 of that whole thing. Gallium oxide. I think gallium is underneath aluminum. It is, so it gives 3. Oxygen, over there on the right of the table, takes 2 valence electrons. 3 valence electrons, 2 valence electrons. Not a match. Switch the numbers, because you have to move 6. You have to have 2 3s and 3 2s. So it should be Ga2O3. Ammonium carbonate. ammonium carbonate. Well, ammonium is NH4 positive. Carbonate is CO3 2 minus. Carbonate took 2 valence electrons. Ammonium gives 1 valence electron. This is not a match. I have to have 2 ammoniums, so it should be NH4 2 CO3. No charges in your answer. If you leave charges in there, it's wrong. Calcium hydroxide. Okay, this is an ide, but I'm not going to ask you hydroxide on your quiz because it's the only ide that you have that is not a binary. So I want you to do it all the odds. Ides is binary. But hydroxide is OH and it has a minus charge. Calcium is Ca. It has a 2 positive charge because it's in the second column. Calcium gives 2 valence electrons away. Hydroxide takes 1. This is not a match. How do you deal with that? You have 2 hydroxides. And this is your answer. Don't leave charges in your answer. And the last one is boron sulfate. Boron family is right above aluminum. Boron gives 3. Sulfate ion is SO4 2 minus. SO4 2 minus. Boron's 3 plus. Switch the numbers. You have to have 2 3s and 3 2s. So it should be B2. SO4, there's 3 of them, so I have to have that whole thing in parentheses. A lot of practice for you there. Here's some more practice. All of these are ionic. So let's do the binaries first, and then let's do the polyatomics. So this one should be calcium chloride for naming. If you can do this, bam, you got your test down, your quiz down, This one should be aluminum bromide. So I would go through and get all your ides done for your binaries and then do your polyatomics separately. And then strontium fluoride, strontium is Sr. You can look that up on your periodic table and use this guy. Strontium is here. Not yay. I forget what the other one is, but it's one of these over here. Fluoride, I think, which is a -1. Yeah. So strontium gives 2, fluorine takes 1. This is not a match. I need another fluorine. SrF2. And lithium is way over on the left, gives 1 valence electron away. Oxygen is close to the right at the top, takes 2 valence electrons. This is not a match, so you have to have another lithium. It should be Li2O. Now your polyatomics. Ammonium phosphate. You just look those 2 up on the table. And this is potassium, and from the table, acetate. Potassium acetate. And then you have to name some. You've got ammonium and chlorate, both of those are polyatomics. You've got an NH4 from the periodic table and a ClO3. Ammonium is a +1, gives 1 valence electron. Chlorate is a -1, took 1. That's a match, it's just NH4ClO3. Boron carbonate, boron's from the periodic table, it's B. Carbonate is CO3, 2 minus. Carbonate takes 2, boron gives 3. Not a match. You can just swap the numbers here. B3, CO3, 2. I've got ammonium phosphate again, which I have right up here. Ammonium gives 1, NH4, there's got to be 3 of them because PO4 is 3 minus. The phosphate takes 3, ammonium gives 1, not a match. I have to have 3 ammoniums. And sodium nitrate should be, nitrate is NO3, NaNO3. Nitrate takes 1, sodium gives 1, that's a match, it's NaNO3. There we go. That's the ones we just put on the board. Okay, now, I'm gonna go to the chapter review on the next video, which is PS26BBlake.